Okay, so we're recording. This is going to get posted on the Canvas. Listen up. Actually, look back here too. I want to make sure that they can hear me on that as well as addressing you guys. Let's talk about homework a little bit. Okay, so we want you to try. But I don't want you to stress so much that you make yourself sick, Mills. You don't stress? Okay, I don't want you to do it that much. Homework is graded for completion. Now and then we're going to do an assignment where we'll do a homework quiz, but we don't do it very often. For the most part, homework is graded for completion. Now, that brings up an issue though. Maybe I'm old-fashioned, maybe I'm naive, but I expect you to give an honest effort, and your homework represents your work, no one else's. Now, that doesn't mean that you can't call someone or you can't ask somebody a question on how to do a problem. I expect that. I'm in my master's class now, and Mrs. Whaley and I are in the exact same program, and we talk to each other all the time about, hey, what did you do? What do you think he was asking when he was asking this question? The professor. All the time, and that's at a master's level class. And so I expect you in geometry, you're going to struggle at some point in time. It's okay to talk amongst yourselves. But it's not okay to just copy down work and you don't understand how it happened. Do you see the difference? Okay. And so it's like I tell my son Andrew. Sometimes he got it, sometimes he didn't. Just because you can get away with something doesn't mean that it's okay. There's probably a chance that you could get away with cheating. That doesn't mean it's okay. Does that make sense? And again, maybe I'm old-fashioned, maybe I'm naive, I don't care. That's what I believe. You should have a little conscience in your heart, in your mind, that tells you, I probably shouldn't just write this down if I don't know what I'm doing. If you don't have that conscience, I hope you find one during this class. The old phrase, if you ain't cheating, you ain't trying, doesn't apply in geometry. Yeah, does that make sense? I'm here to help you. I want you to succeed. But I will give you the grade you earn. I will know as well if you're turning in all your homework and you're completely bombing the quizzes and the tests, something's not right. I've learned from experience that if you're doing and comprehending the homework pretty well, doesn't mean great, like awesome, but pretty well, you're going to do pretty well on the quizzes and the tests because they are closely related. That makes sense. Now, that being said, there has to be some consequences for not doing your homework. As a school and as a department and as a teacher, now that we're somewhat kind of normal about COVID in-class instruction, the first time that you do not submit an assignment, I'm going to give you a warning. Tehran, I might say, hey Tehran, there's your warning. Got it? I'm not trying to shame you. I just want you to know that assignment. You want me to pick on someone else, Mills? No. I was hopeful. I'll pick on Troxel. I know he can take it. Troxel, on the second assignment that you decide not to turn in, I'm going to email your parents. I'll probably throw Kenny in on that email. Got it? And I'm going to say, this is his second assignment. Does second assignment. Okay? Now, let's say you miss an assignment or two. You can still do them, and you get half credit. Okay? And that's open throughout the entire semester. Okay? All right. Third assignment. Now it's a detention. Got it? So those are the consequences. And that's just because we want to provide a framework that you get your homework done. It's important because it helps you understand the concepts, which is ultimately what we want. Does that make sense? We good with that? All that being said, I don't want you to stress at an unhealthy level. Okay? But I also don't want you to think, oh, it don't matter, and not care. I want you to care. But I don't want you to care to the point you make yourself sick. You got to find that middle ground. Got it? And that's where I want us to exist for the entire school year when it comes to homework. And so as you were asking Mr. Renz about what do, I was intentionally vague. I'm still trying to figure out how I want to make the assignments due. We don't have our phones in class this year. So last year I would just say, get your phones out and submit it. You know what I mean? We don't have that this year. So I'm still trying to figure out how I'm going to make that. I think we're just going to wait until the next day after we go over the homework and make it due that night. So it'll be like a day delayed. Okay? And so sometimes we'll have class time to go over the homework, but sometimes we won't. Today we do. We go over the homework for a few problems. Okay? Does that make sense? And we're actually going to add to the assignment. All assignments are submitted via Canvas. Okay? We're going to get through about 3 sections, and then we're going to start talking about taking a quiz. All right? Throughout the whole year. 3 sections usually means it's time to get a quiz in. And I want to make sure you're getting it. And that's one way that I can. So I can look at a quiz, which isn't a homework assignment. It's not graded on completion. It's graded on accuracy. I can tell then. Does that make sense? We got it? We on the same page then about homework? Collective. It's okay. If you're not worried, like not stressed at all, well, then maybe you need to get stressed a little bit more. So I want you to care. Not too much. We're unhealthy. Is that confusing or are we clear? We good? Okay, good. All right, so that being said, let me get attendance. You guys need to get your compass and straight edge out as we get going here today. All right, I already submitted that. We're good now. When you get back to your seat, turn to page 7 and get your notes out. No Kobe. Page 7, there's some terms in bold. The first one is coplanar. That's how you spell it. Coplanar. So you can see it on the screen. Let me connect. Coplanar. Yes. Tyler, you are a mess. Absent, don't look at Canvas. Now you forgot your book.
Sorry.
Are you? Don't just say it. Thank you for being honest. Go get your book. Hurry up.
Thank you.
Coplanar means items, whatever they might be diagrams, pictures, in the same plane. A plane typically is represented in a parallelogram like that. And so we could have a point in a line like that. Items in the same plane. Coplanar. We could have parallel lines. That's also a term that is in bold. Parallel lines. Parallel lines are two lines which never intersect and are coplanar. Two lines never intersect and coplanar. All right, so here's a question. Does anybody think of an example of when two lines would never intersect but not be considered parallel? Let me say it again. Two lines which never intersect but not be parallel. They are called, this is not in your book, so write it down. Skew lines. S-K-E-W. It's kind of fun to say. Skew. Skew. Skew lines. Never intersect, but not parallel. How can that be, Loy, Ethan? How can that be? How can we have two lines? Let me keep talking so you can think about it. How can we have two lines that are not parallel, but they never intersect? Any ideas? So sideways, the same length like this, but wouldn't those be parallel? Huh? Tyler, over there. Volume 1. Don't grab volume 2. Volume 1. Any idea, Lloyd? Farmer, how about you? Any idea? Mills. Renz. Nope. Traxel. Any idea? Okay, I'm going to try and draw it on the paper. It's kind of hard to show actually on paper. I'm going to try and draw it, but then I'm going to have you look at me. Bryant, want to take a guess? No. Okay, it's like this. Okay, so think of it like this. Here's a line that's kind of going back into the paper. And then here's a line that's going up and down. Okay, look back here. This will be a better explanation. I have a pen, I have a pencil. They're both lines. Got it? So, like a laser. Got it? Laser. Mills, don't make fun of me. Jeez. Laser. Got a laser going right there. Got it? Everyone see it? Imagination. Got it? And here's one too. It's like a rocket. Now, you see it? Here's the line of the rocket, and here's the laser. Ooh, how do I do that? No. Up, out. Will they ever intersect?
No.
No. Are they parallel? No. Remember, parallel means they never intersect, but they're in the same plane. Are these in the same plane? No. That's called skew. Okay? I'm going to show you another diagram on the paper to help illustrate it a little bit. Try and draw this. This is kind of fun to draw. Here we go. Here's an XY axis. Does everyone see it? XY axis. Now we're going to add another axis. Ooh, fun. Watch. This axis is called Z. And it literally comes out of the paper like this. Straight up. It's coming straight up. And so the dotted line represents like it's going back into the paper. Haley, does that make sense? Can you see it? Visualize it? 3D printers work like this. Okay? And so then think of like a line. I'm going to use a different color. Think of like a line that's out here, intersects the Z out here, and then a vertical line that intersects the Z and goes down way back behind the paper. Does that make sense? So this one's way out in front, and that one's way back behind. Those are two lines which would never intersect, but are not parallel. They are skewed. Good? Hold on, I want to work with you guys on something. I'm going to pause this just a second. Pause. All right, should be good to go now. All right, we just finished skew. All right, let's move to the next thing I want to do. In your book on page 7, it also has this. It's called the segment addition postulate. The segment addition postulate. And what the segment addition postulate says is that if 3 points A, B, and C are collinear, which we talked about yesterday, collinear, meaning they're in the same line, like this, A, B, and C, 3 points are collinear, then, boy, I like if-then statements. If you played basketball for us last year, then you got to enjoy Tia's famous cookies. Right, Coy? Yeah. Not this year, though, Landon. And Brian's like, oh. If you take out the trash, then you might get an allowance. If you don't do your homework, then you will fail. Yep. If then. Okay, so this says, if that's the case, then here's our conclusion, that the segment AB plus the segment BC is equal to AC. If then. Okay, so what does that mean? Well, I'm not measuring it, but let's just say that we have this has a length of 8 units. This has a length of 9 units. So then we know that the entire thing is 17 units. That's just an example. That's called the segment addition postulate. Let's work with that on math this way. What if we knew that AC was 22 and AB was 10? Then what would be the length of BC? It has to be 12, right? Kaylee, does that make sense? Okay, that's called the segment addition postulate. We literally will use this postulate the rest of the year. It'll be little different versions of it, but the concept of the segment addition postulate we use the rest of the year. We apply it to arcs, we apply it to circles, all year. Okay? Segment addition postulate. By the way, a postulate is an accepted truth statement. It's not proven. We just accept it to be true. Okay? All right, get out your compass. Start off with a line. You got to look at the screen so you can see exactly how this is happening. Okay, so I'm going to start with a line like this. Start with a line. Now I'm going to get a compass. I'm going to create, well, just a random, make a random segment. Let's call it A, B. Let's just make a random segment. Does not matter how long it is. All of you might be a little bit different. Okay, so now look at the screen. I'm going to put the sharp part of my compass on A. If you don't have a compass, make sure you get one over there. Tyler, you got a compass? Yeah. Look at you. Yeah. Alright, so now when I open that up, you can see that it's not quite long enough. If I draw an arc there, that's not the length of AB. I'm a little short. So I'm going to widen it out a little bit so you can see, get my hands out of the way. If I go too far, that doesn't work either. I want it to go exactly the length of B. So what we're doing right now is we're going to copy. Oh yeah, perfect. We're going to copy. Now don't let this move on you, because this distance right there is AB. So don't let the compass move. Okay, and so we're going to copy segment AB. That's what this is, copying a segment. That's the construction. All right, so I'm going to put a line down that I'm going to copy. I'm going to copy onto. I'm going to start with a random point. We're going to call it C. Doesn't matter where it is. I didn't move my compass, as you can see. Got to be careful. Maybe it moved on you. If it did, just go back and do it again. It's not a big deal. There we go, AB. And now I'm just going to take my compass and move it down to the other line at C. And then I'm going to make an arc on the line. Everyone see that? Where the arc intersects the line, I'm going to put a point, and that's called D. And so therefore, AB is equal to CD. We just did our first construction. Hey, everybody, raise your hands straight up in the air. Right hand, straight up, high. Come on, Teron, high, way up. Right hand. Okay, then reach behind your head. Look at this, back here, like this. Way back to right in the middle of your back, okay? Look, and then do this. Go like this. Go ahead. Good job. You just did your first construction. Well done. It's also a good stretch. Okay, what are we doing here? All right, so we did the first construction. Let's do a couple problems from the homework. No, let's do an example first. Top of page. Top of page 8. Look at that. 8. All right, now you got to look back here at me towards the book, because you're not going to understand what I'm telling you to do. We're doing example 1, part B, which is at the top of page 8. All right, look back here. I'm going to take my compass. I'm going to my book right here, and I'm going to find the length of AB at the top of the page. So I'm literally going in my book and finding the length of AB. That's the length of AB. Go ahead and do that. And then I have a line with a point A on it. And I'm going to copy AB on that line. You can do it in the book. You can do it in your notes. Don't care. So that is AB. I just copied it. Now I'm going to go back to my book, that other line, which is CD, and I'm going to find the length of it. There's the length of CD. It's a little smaller. But since we're trying to represent AB plus CD, I'm just going to start where B ended, right here. So that when I'm done here, which I'm going to be, create a point there, that's CD, but if I add those together, that's going to be representative of AB plus CD. Does everyone see that? So from here to here is AB plus CD. Another way to say it is that's the segment addition postulate. AD. Got it? Got it? Got it? Good. All right, let's go to homework assignment. Let's do number 25. Coy. Yeah? Coy, number 25. Can you read it out loud for me? It's on page like 16, I think. Maybe 15. 14. I think it started on 14, but I think number 25 is on 16. 25.
What about the city planner?
Yeah, the one about city planner.
So the city planner designs a park that is quadrilateral with vertices at J, -3, 1.
Hold on, -3, 1. I'm going to go ahead and plot the point. Those of you that are listening, please do as I'm doing. -3, 1, J. Okay, thank you, Coy. Next one.
K is 1, 3.
1, 3.
L is 5, -1.
5, -1. Hold on, hold on. Okay, go ahead.
M is -1, -3.
-1, -3. -1, -3. Okay, we got it. Now that's quadrilateral, right? Let's connect it to make sure. Don't read the rest of the problem yet, Coy.
Okay.
Not yet. Why is everybody out in the hall already? Okay, so there's our quadrilateral. Okay, Coy, read the rest of the problem.
There is an entrance to the park at the midpoint of each side of the park. A straight path connects each entrance to the entrance on the opposite side.
Okay, hold on. The midpoint. So let's look at our diagram. The midpoint would be like right here. Like right here. Like right here. And like right here. Hey, you want an interesting fact? Okay, if we were in a park in London, United Kingdom. London, United Kingdom. The park would be a cemetery. Interesting fact. My wife, now this is a true story. My wife and I went there for our 25th anniversary. And the people that we were with, they said, hey, do you want to go for a walk in the park? And we said, sure. So they tell us where to go. We end up there. It's a cemetery. I am not kidding. Kids are running around the grave sites. They're setting blankets down and having a picnic. There's a cafe at the entrance. People are walking along carrying coffee. You know why? They don't have much space. They don't have, like green space. And so they literally use the cemetery as the park. People are riding their bikes through the cemetery. It's kind of weird. But pretty interesting. That's not us. Okay. So then, those are the midpoints, right? And then what's it say to find, they connect for a trail going across. Did it tell us to make a diagram? No. But is it helpful sometimes?
Yes.
Oh, yeah. Okay, questions so far? All right, so we got to find the midpoint. We got to find 4 midpoints. We're going to do these fairly quickly. Stay with me. Let's find the midpoint between J, K. There are the coordinates right here, so I'm not going to rewrite them. They're right there. The midpoint formula, I'm going to call this M sub 1, so it's different than this M. I add the x's and I add the y's and I divide by 2. So -3 plus 1 divided by 2 1 plus 3 divided by 2. Negative 3 plus 1 is negative 2 over 2. 4 over 2. You can do this in your head. Negative 1 and 2. So M1, or the midpoint of JK, is at negative 1, 2. Negative 1, positive 2. About right there. There's the entrance. We're going to call that M1. Everyone okay? I'm going to go a little quicker now. All right, let's do K and L. Okay, 1 plus 5 over 2. 3 plus negative 1 over 2. This is M2. 6 over 2 is 3. 2 over 2 is 1. 3, 1. 1, 2, 3, and 1. Right there it is. We're going to call that M2. Okay, now we're going to do L and M. This is M3. L and M. 5 plus negative 1 over 2. Negative 1 plus negative 3 over 2. That's 4 over 2, which is 2. That's negative 4 over 2, which is negative 2. 2, negative 2. 2, negative 2. Right there. We're going to call that M3. All right, last one. JM. We're going to call this one M4. Sub 4. Negative 3 plus negative 1 over 2. 1 plus negative 3 over 2. Negative 4 over 2 is negative 2. Negative 2 over 2 is negative 1. So M4 is negative 2, negative 1. Negative 2, negative 1. That's right there. That's a pretty good diagram. Everyone, did I lose anybody? Kaylee, we still good? Troxel? Okay, so now what do we got to do? Well, we got to find the distance. We got to find the distance from M1 to M3 and from M2 to M4. Because aren't those the entrances across the cemeteries? Or the parks? Okay, so M1 to M3. What was M1? That was negative 1, 2. What was M3? That was 2, negative 2. So I'm going to find the distance between those 2 points. Here we go. Distance formula, negative 1 minus 2 is negative 3. Negative 3 squared is 9. 2 minus 2 is 4. 4 squared is 16. Oh, that one's easy. So the distance from M1, I'll use red. So the distance all the way across is 5 units. Okay, now let's do M2 and M4. Where's M2? Right here. Where's M4? Right here. Okay, so the distance, I'll give myself a little separation. The distance is equal to the square root of 3 minus a negative 2, quantity squared. 1 minus a negative 1, quantity squared. 3 minus negative 2 is 5, that's 25. 1 minus 1 is 2. 1 minus negative 1 is 2. 2 squared is 4. And so we have the square root of 29. So now, the square root of 29 is a decimal. I think it's about 5 point, yeah, maybe 3/8 if we do hundredths. Isn't each unit worth 10? Don't they say that's 10 meters? So that means 5 units is 10 meters or 50 meters. And this would be 53.8 meters. If we add the two together, our trail system connecting the entrances is 103.8 meters. That's number 25. That is the correct answer by the book. Any questions? Yes? That'd be fine. Yeah, that'd be fine. I really like this problem because it used midpoints and the distance formula. And that's good. That's a good practice for us. Okay, I'm going to pause and stop there. Here are the ones I want you to add to your assignment. There's 4 problems. Number 5, number 6, number 27, number 28. Add those 4 problems to the assignment for today. If you didn't get today's assignment done, you got to get it done. Add these 4, and then we will go over those, turn them in tomorrow. Got it? So you got tonight, everything.
I did it.
And now Cassie did it on paper. We want you to do it on the book paper. That's fine. You can turn it in now because I wasn't very clear. But you'll find that it's a lot easier to just do all the work in the book because sometimes they're going to give you a grid. They'll give you things that you need to use. Okay?
So you want us to show our work in the book too?
Yes. So try and show all your work. There's usually enough space that you can use the book to show. Yeah, it's okay for this assignment. Not a problem. Why? I know, why? Okay, signing off for the recording too. Any questions, let me know.